All right. Okay, let's look at part 2 of the review. So to graph this, I just made an input output chart. I just did in my head though. So if you sub in 0, anything to the 0 power is 1. Sub in 1, 2 to the first power is 2. Sub in 2, 2 squared is 4. Sub in 3, output is 8. Sub in 4, 16. And then negative exponents would be reciprocal. So 2 to the negative 1 is 1/2. 2 to the negative 2 would be square it, 4, but reciprocate 1/4. So I just graphed those. Domain, all reals, range, 0 not included, that's an asymptote. So there is an asymptote right there, okay? X-intercepts none because we have an asymptote there. Y-intercept crosses at 1. Vertical asymptotes, no. Horizontal asymptote is right here, x-axis, y equals 0, okay? Now, to find the inverse, okay? So remember, to find the inverse of an exponential would be a log. That's why they exist. So with this, I have my base, my exponent, my answer. Okay, 2 is my base, y is my exponent, and x is my answer. Now, this is after I flip, right? Because to find an inverse function, remember, input becomes output, output becomes input. So I switched those, I flipped them. Now I'm going to solve this. So logs eat the answer, x, the base comes down here, and they spit out the exponent. That's their job. And then usually we rewrite y as f inverse. So it should make sense to you that 2 to the x power is exponential. A log base 2 would be the inverse of that. Okay, now this one says graph the inverse. Okay, now remember, it should be symmetrical around y equals x. Is that okay? Probably the easiest thing, again, for me, I don't like graphing logs, is I would graph the exponential and I would just flip my points. Okay, so like there should be one at 16, what, 4. So if I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. What is that? 1, 2, 3, 4. So at like 16, 4, I should have a point. Okay. At 8, 3. So if I go over 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, I should have a point at 8, 3 because output and input are flipping. Here, this should be at 4, 2, 1, 2, 3, 4. My room's getting kind of dark, so it's kind of hard to see. 4, 2. And then what? 0, 1, I should be at what? 1, 0. And then at a negative, so at half, I should be at a negative 1. At a fourth, I should be at a negative 2. So this guy is going to go like that. And again, it should be a fold symmetry along y equals x. This should go. And notice your asymptotes change too. Here, asymptote is right here. For my log function, my y-axis is my asymptote. So that one actually is a vertical asymptote. And the other thing that flip-flops is your domain and range. So if this is your original domain for the exponential, that's going to become your range for the log. And if your original range for the exponential, that's going to become your domain because input and output switch, okay? All right, so make sure you can do that. On the next page, again, if you want to find the inverse function, remember input becomes output and output becomes input because you're trying to undo it. So I change this to an x, change that guy to a y. First of all, you have to isolate the function. So I divide both sides by 3 because these cancel. I get x over 3. Next thing, this is isolated, right? That's the best you can do. And this is why logs exist. If they didn't exist, we'd be guessing and testing our life away. So what do logs do? Logs eat the answer. This is spitting out the answer. So logs eat the answer. The base comes down here and they spit out the exponent. So the job of a log is to eat the answer and spit out the exponent. Okay, now when I have that, then I want to solve for my y. So I subtract y from both sides, and that's outside the log function. So you're going to have log base 2 of that minus 1 equals that. And again, usually we write it as, G inverse, F inverse, something like that. All right, the next one. Say you want to graph this. Okay, again, transformations are the same pretty much on everything. So if you think of like, what would this same transformation do, but to a parabola, right? It's going to, shift if this is your parabola, right? It's going to shift it 3 to the right and 7 up. Okay, so on this one, you would graph 2 to the x like we did on the first page. You would shift it 3 up Okay, or sorry, I misspoke. 3 to the right, that would help. Okay, so because we're talking about the x, 3 to the right, and then 7 up. Okay, so at first you'd be looking like we initially had it. So then I would shift all my points 3 to the right. So where in this one, you know, I could take all these points and shift them all 3 to the right. Every single point, just shift it 3 to the right and graph that. And then I would shift it up by 7. And you could graph it on, excuse me, Desmos if you wanted to see that too. All right. Say you don't know how to graph logs, and I don't really like to graph logs. So what I would do is, again, I would do the inverse function. Okay. So let input become output, output become input. So this became my x, this became my y. Isolate this function to begin with to subtract 2. Now I have a log. Logs eat answers and spit out exponents. And if it says log, that means you're base 10. So I'm in base 10, my exponent x minus 2, that's not there yet, right? It equals y minus 4. Now I'm solving for the y. To get rid of minus 4, I add 4 to both sides. And again, that's outside the function. Rewrite it. All right. How would I graph it? Well, I would graph this. So I would graph 10 to the x. Then I would shift it 2 to the right. I would shift it up 4. And then I would reflect that over y equals x. So kind of what we did here. I would graph the exponential, and then I would, you know, reflect it over y equals x. I just think that's easier to get the log function. All right, condense, okay, and this is a 7, I believe, right there, hard to see. Okay, when you condense, you get to write the word log once. Everything has to be inside the parenthesis with 1 log. If it's natural log, you write natural log once. If it's log base 8, you write log base 8 once, okay? All right, now everything should go in there. Positive coefficients are in your numerator. Negative are in your denominator, and these go back to exponent rules, okay? So when you have a power to a power, you multiply. So that 2 is really up here as a power to a power, so x squared. Again, power to a power, you put that back in y cubed, but it's negative, so it's really down here because, again, with exponent rules, you really subtract exponents when you're dividing. So if you have a negative coefficient, it's down here. 7, again, I can put that back as a power to a power, z to the 7th, and then minus is really dividing because, again, when you divide, you really subtract exponents. So a power to a power, you really multiply. Here you do that, okay? All right. And again, the other rule that I didn't talk about is x to the 5th times x squared. When you're multiplying, you really add exponents, okay? So you're just undoing that. All right. If you're expanding, count how many things you have, coefficients and variables, the whole bit. So I have 1, 2, 3, 4, 5 things. So I'm going to write natural log 5 times, okay? Here, when you condense, you get 1. Here, I need 1 for each little thing. So 7 is in the numerator, positive, because I'm adding. X is in the numerator. Put it there, 5. Now, the 5 can come down. This is really natural log of y to the 5th right here, but I can bring it down because a power to a power you multiply, so I can bring it down. Anything in the denominator is subtraction because you divide, that's when you subtract exponents. So minus, because it's in the denominator, ln of 8 minus ln of z. And again, if those had exponents, you could bring those down too. All right, I'm going to pause there. We'll continue on. Okay, my review kind of printed funky, but I just fixed it. But I fixed it for you guys. Okay, I'm going to solve these. Remember, single log, single exponential, and then double log, double exponential. I mean, that's basically what we do, right? We just do inverses, right? And so single goes to single, double goes to double. All right, so first of all, there's no triple, so we got to condense. When you're adding, you're really multiplying. All right, I have a double log, okay? Now, some people are just like, well, if you have a double log, you can just take them away, which is true. In a sense, what you're doing is if you have a double log, you're doing a double exponential, but again, or double exponential, but again, base 10, these guys would cancel because log base 10 of 10 would cancel. So if you have double logs, that means they're both eating the same answer and spitting out the same exponent. So, you know, you can just cancel them, but however you want to think about that, that is okay. So x is 10, and we'll check these with graphing at the end, okay? All right, let's look at this guy. He is a single log. He's already isolated. Do you see that? So single log. So I'm going to go to single exponential. All right, logs eat answers and spit out exponents. And so the base is 4. So there's my base, there's my exponent, and the answer is over here. All right, so I get x squared. So this is definitely a quadratic. I'm going to bring the negative 16 over. And hopefully this guy factors, let's see what, 8 and 2 sounds promising. All right, I want more negatives. So I want the negative on the 8 and I want less of the positive. So I can get a negative 8 and a 2 and get that. Set each piece equals 0, because remember, we like linear and we like quadratic, which basically, turn into linear unless it's a quadratic formula. All right. Now, check your answer. Just because you have a negative doesn't mean it's a no-no or 0. You have to sub it in. 8 squared, 64 minus 48, we're going to be fine. Negative 2. A negative 2 times a negative 2 is what? A positive 4 minus a negative times negative would be a positive 12. So even though this is a negative 2, when I sub it back in, I don't get a negative. So I am thinking I'm going to get 2 answers there. Again, I'll check it with graphing in a little bit. All right, let's look up here. All right, so this looks like what? Double exponential, so I got to go to a double log. So I'm going to do a log to both sides, and we usually do natural log. You can bring down the exponent, but again, you need parentheses on that. Bring down the exponent. And that's what, ln of 3. All right. Okay, now you need to do the distributive property on both of these. Okay, so you're going to distribute. So you get ln of 2 times x plus ln of 2 times 5. And then over here, you're going to do the same, ln of 3 times x plus 3 times ln of 3. So you're just distributing that. And I'm going to pause here and write it so I have more space because I'm kind of cramped. All right, I got more paper here. So just distribute. Now here, I would be a little careful. Ln of 3 times x is fine. I would probably write it as x times ln of 3 because that's really coefficient. Same thing with this 3. I would put it out front just to be safe. So again, I would rewrite these where the coefficient is in front. You don't want to accidentally think that that x is part of that 2 or any of that, okay? Because that function eats that input, that's separate. Okay, I want to solve for x. So I want to bring my x's to this side. So, and again, the way you move things is with adding and subtracting. When you have adding and subtracting, I have a positive, I'm going to subtract it. So I get x ln of 2 minus x ln of 3. And don't forget, I mean, these are numbers, right? Like natural log of 2 is a number. All right. The only way to go from having 2 x's to 1, and you can't add them because they are not like terms. Okay, if you turn them into decimals, they would be, because you'd have some decimal times x, another decimal times, x, you would be. But I am doing natural log. So what I'm going to do is factor that x out. So I'm going to pull that x out. And that's the way you can go from having 2 x's to 1. Okay, and if you distribute, you can see it would come back. All right. And again, these are just numbers over here. And then divide to solve for x. So isolate and inverse is how we solve every equation in the whole wide world. So I believe that x equals this. Now again, I can convert this into a decimal, to make sure I'm right, or I can graph it, and turn it into a decimal that way and see. All right, let me pause and I'll switch back. Okay, again, you can do single and double, not a lot of extra steps. So first I'm going to minus this 5 over to both sides to get a 3. And then again, you can't have this situation. You might be like, well, I'm going to add it to the other side, but then you have 3 things. So you need to condense this. So natural log, and the way you condense subtraction is by division, because that's your exponent row. All right, I have a single log. I'm going to go to a single exponential, and it's base e. So e to the 3rd power spits out that answer. Okay. All right, now to solve this, kind of depends on what you like. If you like to cross multiply, I'm going to, let's see, what do I have here? I'm probably going to multiply both sides by x minus 2. And again, I'm going to pause and get more paper here. Okay, so to finish this one, I cleared the fraction, multiply both sides. Remember, we don't like those. Distributed, so that. And then I put all my x's on one side and my other stuff on the other side by adding or subtracting. To go from 2x's to 1, I'm going to factor it out. This is what's left. There is a 1 when you factor that out, and then divide both sides. And you should get that as your final answer, okay? So kind of like with the natural logs. Now, if you hate this, you could convert e to the third into a number, like 3 or 4 decimal places, because that is a number, okay? So all I did is distributed, all right? Then to get rid of a negative, I added to both sides. To get rid of a positive x, I subtracted both sides, factored out my x, and divided. And again, we can check our decimals to kind of see. So far, we have 1 more. So we'll see if we can squeeze 1 more in here, and then we'll go from there. I don't know if I'm going to get cut off or not, but we'll find out. All right, isolate the function. So add 1 to both sides. So I'm going to get, 16, okay? Isolate the function again, so divide. All right, I have a single exponential. I can go to a single log. So logs eat answers. The base goes there, and it spits out the exponent, okay? All right, so then I am going to, usually we do natural log a lot of times on that. So natural log of 8 over natural log of 5, change a base formula, the log of the big over log of the little. And I'm going to subtract the 1 from that. So minus 1 equals 2x. And then I'm going to divide all of that by 2. So x equals, now you might see it this way. That's kind of ugly. What some other people might do is, and I would be okay with that. I'd be okay with this in decimal form too. But this is really 2 over 1. So you could multiply by the reciprocal and take like this times a half. So take this times a half and that times a half. And so ln 8 over ln 5, and there would be a half there. And then what is that? Minus a half. That would be a legal answer as well. All right, I'm going to pause, and then we will convert some of these into decimals and check our answer here in the next video.